Dear friends and dear colleagues, welcome back to the second lesson on the manufacturing of the prosthetic shell to be used together with the technique, Weldman technique or chronometric technique. We have seen in the previous lecture the construction of the analog shells, and today we will see the same steps for the making of a digital shell. So we have together with us once again our lab technician Gianluca Siginolfi, and I will make a short introduction and then I will let Gianluca go on. So we can make digital shell by means of some CAD/CAM procedure, or today also more and more with 3D printing. Let's start with CAD/CAM. What are the benefits and the drawbacks of these shells? Well, the benefits mostly are because they are monolithic shell. And while analog shell are the result of the assembling of multiple denture teeth, here you mill from a block a one-piece shell. So it is definitely stronger. The second advantage is the low wearability. This is due to the particular properties of this material, that in some cases, some of these materials have really a very low abrasion rate. Physical properties are better in some of these material. They need less time to be manufactured, and lab technician often is not required. So you can go home now.
No, yes, because in the digital approach, some dentists have a camera, have a software, and quite often have the milling machine. And for this reason, I think in some case, it's a good idea to make the restoration directly in the office.
Among the drawbacks is that if the dentist has to make himself this manufacture, obviously he has to invest some budget to buy equipment and machine that are expensive. And obviously this machine will be used to make a number of things. But even so, compared to taking a couple of alginate and sent to the lab, it is definitely a procedure that requires to have some budget invested. Learning curve. Learning curve because you need to learn a software, and sometimes these software are not so easy to understand, and you require some training and time. And very often the software are upgraded continuously, and sometimes the upgrade is very good, but it forces you to start back to learn the new software. So basically, it requires a little bit of time. And aesthetics, why aesthetics?
And the aesthetics sometimes is not good because the color and the shade is not the best, because the blocks and the disc are have only 1 layer or 5 layer or 7 layer, but is not the best cutback of the enamel for sure. And the milling machine don't have the best result during the milling process. And is important by the dental technician or by the doctor to increase the shape after the milling process.
Okay, so we've seen some of the pros and some of the cons. Okay, so we will see now some of these procedures. Let's start with the blocks. This material is available in block or disc. Blocks normally requires a 4-axis milling machine and disc a 5-axis machine. So more often the dentist that like one day dentistry has his own 4-axis machine. It's not likely that the dentist has a 5-axis, also because 5-axis, as far as I know, is slower compared to the 4-axis. Okay, so basically I think that as far as the dentist is concerned, we should talk about 4-axis machine, and this means blocks. And when the lab is involved, we will also discuss about disc. So today we see both. Let's start with the blocks. And obviously, let's start with long blocks. Long blocks means blocks that allow you to make a bridge. We have a separate lesson where we discuss the construction of shell for single teeth. Okay. In this lecture, we discuss only bridge and full arches. So those materials that are available in blocks, but only in small blocks, so restricted to single teeth, will not be discussed or presented here. Okay, so let's see some of the materials. Maybe you want to present this material or not. Okay, VitaCAD Temp.
VitaCAD Temp is a PMMA. Look, the material is 86% of PMMA, and filled the remaining part by the inorganic material.
So his flexural strength is not so strong, but we will see all these materials have a poor flexural strength. The difference between the three materials is that you see CAD Temp has a lot of PMMA and 14% of filling, right? While the others have different percentage. So VitaCAD can be monocolor, multicolor, and here there is the description of the inorganic microfillers that are polymerized in a network that give us good properties, although as you see, not a very high flexural strength resistance. This is why the company that suggests the use for this material just for some years, not more than 3 years. So these are basically more addressed to make temporaries than final bridge. TelioCAD is another kind of material. It is mostly PMMA. You see 99.5% and just a little drop of pigments, right?
Yeah.
And it is just one color. So basically, compared to VitaCAD, this is more
temporary material.
More temporary.
Because it's only for 1 year in the mouth.
It's not layered. And so
It's one color for sure.
Okay. The last material that we present you is Ambarino. Ambarino is the commercial name of what is also known as hybrid ceramic. Why is that? Because it is basically half PMMA and half anorganic silica in volume. In weight, as you can see here, is 70% silica and 30% PMMA. So it is much more filled compared to the two previous materials. And this is enhancing a lot the properties of this material, that is more resistant to compression, to abrasion, and still maintaining a good elasticity model. So this material is very useful when you want to make something that is supposed to last a little bit longer in the mouth. So to recap, Vitacat we use for temporary, Teliocat for temporary, and Ambarino we use to make durable restoration. What is durable? Durable means, as you can read here, something made the day of the surgery that is supposed to last for a number of years. So why the other two materials are temporaries, that means that they last for a limited number of months, and basically they are guaranteed for a year approximately. With a durable restoration, we are aiming to make a bridge that we can sell to the patient as a final restoration. Okay, so this is a strong objective. We will discuss this pretty much in details in a lecture that is dedicated just to this point, an entire lesson, but not now. Today we just see the lab technician aspect of the concept. So durability is the result of the addition between three fundamental aspects and points. One is the shell, the second is the framework, and the third is the relining material. These three materials combined together create a very strong synergy, and this synergy is creating this unique artifact that is the durable bridge. In some tests that we have done with the fatigue testing machine, you see that after 5 million of cycles, that are the equivalent of 10 years in the mouth, according to the international agreement and certification, after 5 million of cycles, at the maximum capacity, at the maximum ability of the machine, still our bridge made by 1 centimeter of combo-line composite and the framework has not broken, has not any kind of cracks or fractures. So definitely this is an interesting concept, but we will address this later on. Now let's start to see how we make this shell with the technique direct or indirect. With a direct shell means that, okay, I place implant, then I place the econometric cap without the stem, and then as we have no impression scanning post, then we have to scan the cap. So here the doctor scans the caps with the camera.
Yes. And after, in the software, it's time to shape the new bridge. Before, mark the margin, shape the restoration, check the occlusion, and mill the restoration in one block, like in this case.
And meanwhile, Gianluca is milling this in the lab. You can do everything yourself, obviously, but I think if you're working in a team, it's better. So You save time, okay? I am connecting the econometric cap and just making my framework, okay? I made the framework the way I prefer, but we will see in some future lesson that there are many ways to make a framework if you don't want to use the intraoral welding concept. Then I remove the framework and to Gianluca.
Now it's time to open the slot to place the framework inside the new restoration. And before I mark the shape of the wire and open with the round bar, I open completely the space for the framework. And now it's time to match the two parts in the mouth. The framework with the opaque, place in the right position, tap, and it's time to open the link between the material of the bridge and the Reline composite. And in the mouth, the doctor reline the bridge on the top of the framework. After 7 minutes, retrieve the restoration, and it's time to fill the gap because we have a lot of gap around the cap. Trim and polish, and the bridge is now ready again for the mouth.
And you just have to tap the bridge in position, and that is the final, your final work. So this is your bridge, durable bridge made with hybrid ceramic, and it's a material that we have been using for for a number of years, and we are very satisfied.
For to cut a lot of time, the day of the surgery, the other approach is the indirect approach, indirect technique. Start with the study cast of the patient. The restoration is the bridge from 14 to 17. And it's time to prep the teeth. And with the help of the silicone, we have the vertical dimension of the mouth. And now it's time to start with the acquisition, or with the lab scanner, or with the camera. This is the Prime Scan by Sirona. And start with the acquisition of the upper model. And it's very easy because you have the model in your hand. It's very easy to change the inclination and to read the model before the upper and after the lower model of this mouth.
So you prefer to have a physical model?
I think it's a good option because it's very easy now, the acquisition, and you cut the time of trimming, of shaping time, the trimming time, and you cut, I think, a couple of hours to make the restoration. Now, the restoration is more or less finished. With the help of the jig of silicone, you check the occlusion. And now in the software, it's time to mark the margin and shape the new bridge. Check the occlusion again. And it's time to select the block, place the block in the milling unit. And after the process, when the process is finished, it's time to increase the shape and open completely the internal part of the restoration. Check the occlusion because you have to model in your hand. Open the slot for the welding framework. And it's time to increase the shape, increase the aperture with the diamond disc, change some buccal and occlusal surface, some sulcus, and now the block have only one shade. It's time to increase the shade of the bridge, some color in the sulcus, and some color to increase the cut of the enamel, the cutback of the enamel, and cover with the transparent. And only now the restoration is ready for the day of the surgery.
So this is like a summary.
Summary
of the
is
steps.
the summary of the indirect technique, the alginate and the plaster model of the study cast of the patient, one silicone for keeping position the two model, the scanning of the scanner or the camera of the office, one milling machine, one software for to shape the digital bridge, and the material for to change the shape of the bridge after the milling process, and some material for to some glaze for and color for to glaze the surface of the final restoration. And this is the kit, the Weld One Lab drill kit, because in this case you have the bar and the disc, the diamond disc, to increase the embrasure, some rubber for polish, and one disc for the day of the surgery for to cut the titanium stem and wire.
Let's see some more cases now.
Yes.
First case with a telio.
With telio, again, the study cast of the patient, and after the acquisition in the software, it's possible to shape the new bridge. And if it's possible, and if you have the possibility to select if you have the choice to select the multi-layer function, I think it's a good idea to select this. And in this case, you have the empty space for the wire immediately after the milling process. This is the shell ready for the day of the surgery. Open the link between the reline material. After the reline process, it's time to increase the shape, trim and polish, and the temporary is ready for the mouth. Tapping position, and this is the X-ray immediately after the placement.
And some final restoration some years later. Another temporary material, VitaCut temp.
Yes, with the same approach. In the software, this is the multi-layer function, and if you select this, after the shaping of the bridge, it's possible to split the restoration in two parts. One is the aesthetic part, and the other is the structure of the restoration. But we mill only the aesthetic part, and in this case, you have the completely empty restoration immediately after the milling process. And this is a good help because the milling machine works for you and given a completely empty restoration. After some increase, after some step to increase the embrasure, to change just a little bit the occlusal surface, you are ready for the surgery.
Some implant has been placed here, and the shell has been incorporated on the Weld One framework, and finally sit in the mouth. This is the temporary, and later the final bridge. Now our preferred and beloved material that is Ambarino. This is the material that we use the most because we can make, with this material, we can make this durable restoration. Okay.
The starting point of the patient, and again the study cast, the upper study cast of the patient, the selection of the multi-layer function. Now it's time to mark the margin and shape the new bridge and select the multi-layer function. In this way, the software split the restoration into parts again, and we mill only the aesthetic parts, and after the process, we have a completely empty restoration with the right buccal and occlusal surface and empty space inside. Polish, some color if you want, and the shell is completely carving and ready for the surgery.
So, day of the surgery, teeth extraction, implant place where there is bone, abutment more or less parallel, as I'm using straight abutment, cap, and framework made in this way. Okay, so it is very important to use this wire to give stability to the implant because this increases predictability. And obviously, the dentist can use other material if they want to make a framework. They can use whatever material they want to mill chairside. And we are teaching you this technique because this is the technique that we have invented and that we are mastering, and because we think that this technique is really a great help. As you can imagine, in 20 seconds you have done a framework, and there is no other technique, no matter how expensive is the equipment, that can provide you an extremely strong and durable framework in such a handful of seconds. And so we recommend this approach, but you are most welcome to combine this shell with any kind of measure structure you want to use. Go. So this is what you get from me.
Yeah. And now extraordinarily it's possible to increase the framework and add some material, some retention, vertical spurs, and after it is important to cut the length of the retention, cover with the one opaque, and again in the mouth it's important to realign the two parts, the framework, open the link with the dedicated primer, fill with the composite. After the relay process, again, the restoration extraorally, it's time to increase it, to add some material to have a better emergency profile. And now polish, some color to increase the shape. And only now the restoration is ready for the mouth.
And this is just the picture. You see, we put this in full occlusion, and we trust absolutely this material, as you can see from the X-ray. Another option to make a digital shell
is with the help of a 3D printed unit and material to use in the unit, like in this case is for long-lasting temporary, but for us the steps are more or less the same. The two study cast of the patient and prep the bridge with the silicone, keep in position the upper and the lower model. Now it's time to start with the acquisition and in the software it's time to shape the new bridge, change some things, especially in the connection. And now the restoration is ready, and it's time to import in the other software, in the software of the 3D printing machine, and start with the new process. After 10-15 minutes, the restoration is ready. It's time to remove to the unit and place in the light polymerization device for other 20 minutes, more or less. And only after it's time to remove the pin and start with the trimming process. Check the compression, the occlusion, and for sure it's time to increase the empty space for the welded framework. With the diamond disc, it's time to increase the embrasure. Again, check the occlusion, some color, and only now also the 3D printing temporary is ready for the surgery.
Okay, so we've seen CAD/CAM shell and 3D and printed shell, and basically these are used with the indirect approach because they are both time-consuming. I understand.
Yes.
Okay, so obviously everyone is welcome to use this concept also with direct approach. This is requiring a little bit, not a little bit,
A couple of hours for a bridge.
more time. So that is a clinical decision, okay? You have a patient that is flying from wherever. What are 2 hours for a patient like this? This is nothing compared to coming back again and so on. If the patient is coming from the neighbor, maybe it's better to make the indirect technique and having come in a couple of times. It is better for you and for him. So everyone can decide according to the different clinical condition and the different type of patient what procedure fits you better. But basically, printing and CAD/CAM, I understand, are more or less required at the same time. Obviously, we are talking of the 3D printer that we have because there are a number of these machines, and some machines probably are slower and some are probably faster.
Yes.
And, right? So
Yes.
this depends always from the budget.
And the post-curing time
Post-curing time and so
of the material, for sure.
Yes. But at the end, what I see is a limit for at least what are my knowledge that may not be correct, as these things are constantly improved and updated. Of these 3 printing bridge is that the durability of the material at the moment is not comparable to, for example, hybrid ceramic blocks that we are using, right? So it's more convenient to use this material for temporaries. Okay, but one of the advantages versus the disc is that with 3D printing you can print simultaneously
More bridge,
many bridges. How
yes.
many, for example?
I
is
think
this machine?
I think 20.
20.
If you have a shape in the software 20 bridge, and it's possible to print it.
Yeah, so this is really
in half an hour.
Saving a lot of
simultaneous.
time.
Yes.
Okay, so maybe your patient want a collection of bridges, and you can print 20 bridges with 20 different colors, and then you can change the bridge whenever his mood is changing. Okay, jokes aside, let's move to the next step that are disc.
Okay, we have a disc made by every material for sure, and in this case we have a lot of case with a PMMA hybrid or digital denture The first case is PMMA, made by PMMA. Is a lower restoration with the traditional hour approach, the study cast of the patient. Start with the acquisition and prep some teeth and start with the shaping of the full arch lower. Check again the occlusion. And now it's time, the restoration is finished, it's time to mill in the disc. And after the process, you have a completely empty restoration ready for the surgery.
So, you extract the teeth, try the shell, and see if everything is okay. Then put some implants in the established position, make a quick impression with some bite registration material to figure out where are the position of the abutment compared to the tooth anatomy, select the appropriate conometric abutment and coping, and finally connect them with a piece of wire. So now I have done surgery and the first part of the prosthetic. I can give this to Gianluca, and Gianluca can continue.
Yes, now it's time to increase the framework with the help of vertical support. And after it's time to cut just a little bit and cover with the one opaque. And for sure, it's possible to try the framework inside the restoration. And if more or less is good, it's time to check again, but in the mouth. The framework in the mouth. And if it's good, reline the bridge on the top of the framework. Retrieve. Again, add some material. Increase some color. And the restoration is ready again for the mouth.
And that is one case done with the PMMA disc. Sometimes when we need more durability, and we can use a hybrid disc.
Hybrid ceramic disc, but the approach is exactly the same. Start to the situation of the patient. In the lower we have a pink part, we have a hybrid restoration, but in the upper only white shell, and start to the study cast again. Prep some teeth and start with the acquisition. In the software, shape the new full arch upper restoration and place in the disc and mill it. After the milling process, it's time to increase the shape, increase the embrasure, some color, and increase again also the empty space for the Waldman framework, and the full arch is ready for the day of the surgery. And with the same step showed before, we have the final result for this patient, tap in the mouth, and it's finished.
So the first case was a PMMA disc, so it is used normally to make temporaries. In this particular case, as you have seen, the patient has a hybrid restoration in the mandible, so what we call a durable restoration. So he expects to have the same in the maxilla. And you see, because the vertical dimension is smaller here, we decide to use hybrid ceramic so that we can still have a very good durability even if the dimension and the material is smaller compared to the lower. Okay, so this is a way. that is very, very helpful for the dentist because it can provide the patient in one appointment with already a final restoration when there is the indication and the condition necessary to address this. Okay, so let's see another case done with Ambarino.
Yes, with Ambarino material, hybrid ceramic material. The patient has a mobile prosthesis in the lower arch, and I like to have a duplicate of this made by plaster. Now the model in the articulator, and I place some little abutment in the lower arch and start with the same approach. In the software shape, the lower full arch restoration, but after the milling process, I increase the shape and the color. But if you look, in this particular case, we need a lot of pink prosthetic part, and for this reason, I started to place some wax in order to obtain like a mobile prosthesis, but with the hybrid ceramic in the white part of the restoration. After I place in the particular flask, in the injection flask, remove the wax, open two big hole to start with the injection of the new material, and now again close the flask and start to add some pink part. After the curing, it's time to open the flask, retrieve the lower mobile prosthesis, more or less, and now again start to increase the shape, polish, and open the big space for the well-done framework. And only now the restoration is ready for the day of the surgery.
So finally, day of the surgery, flap, osteoplasty. See, this is a square mandible. It's the worst mandible you can meet, you can wish to have, because all the implant will more or less be in one line. So the AP distance is very minimal. So cantilever should not be longer, but the patient wants some teeth. So this is why here I'm using this particular abutment here that is much stronger to support a longer cantilever. So I made the framework after having parallelized the abutment and using the titanium conometric cap. And then I have this very strong framework. I give to Gianluca, and Gianluca continue.
In extraorally, I increase and add some vertical retention, cover the framework with the one pink opaque, and it's possible to try the framework inside the shell, and if more or less is good, the same step in the mouth. And again, if it's good, open the link in the shell and fill with the pink composite and reline in the mouth. After the curing, retrieve the lower restoration, add again some pink composite, trim and polish, and the restoration is ready for the mouth. And look, the mobile prosthesis of the patient, the same plaster prosthesis of the patient, and the final restoration. A lot of copy and the final result.
Put in the mouth and engage by axial tapping on the abutment with the fixation tool. Now this prosthesis becomes a fixed restoration, cannot be removed by the patient, only by the dentist whenever this becomes necessary. Okay, let's see the last
The digital denture approach. Yeah. The restoration is the lower restoration for this patient. The patient has a mobile prosthesis, and after the acquisition, we send the STL file in the external facility because our software is not able to make a mobile prosthesis. And this is the proposal of the external facility. And for us, is good because the midline is good, the occlusion for sure is good, and the shape is good for this patient. And now the facility milled the two parts of the restoration for us, the pink and also the white part, glued in one piece. And more or less is a mobile prosthesis for the patient. Now it's time to open the slot for the well-done framework, and the digital denture is ready for the mouth.
Okay, surgery, same way. Now we have a better AP distance because the anatomy is better. So synchron abutment, 5 degree, parallel, conometric welding cap, and the framework with some reinforcement in the cantilever part. Then this is the shell that has been, the digital denture shell that has been hollowed by Gianluca in order to house the framework, and the final prosthesis trimmed and finished and ready to be engaged with the conometric friction. So, digital denture, it is something that has been around for a while now, especially in the United States. And when I learned this concept from my friend Dr. Lem from California, and indeed he told me that, he showed me that using this kind of monolithic denture, because they are mostly two pieces, but basically they behave like a one piece. You can really minimize the number of chipping, cracking, fracture that may happen with other kind of shell in the medium or long term. So it is important to minimize this complication in order to avoid troubleshooting with patient or also just problems. So it is definitely a good idea, and for Italian market, I think if they could beneficial of some aesthetic improvement, probably they could spread much more. In this moment, I think they are probably not so commonly used. But my opinion is that they are potentially a great synergy. And imagine also for countries where the patient has not a huge budget, a simple well-done framework, a digital denture shell, make a monolithic restoration quite stronger and quite durable. In the long term, I'm talking about tens of years. So it is really something interesting that we are looking forward to see how this will develop in the next time and month. So this is more or less everything for this lesson today. We have seen some of the steps that will bring you to the construction of a digital shell for bridge and for full arches. We have discussed some of the different material and some of the different indications. So in the next lesson, we will see how we make a digital shell or an analog shell for a single tooth restoration. So we say goodbye and we look forward to see you in the next lesson. Bye bye and arrivederci.